we'll get started. I just want to say good morning, everybody, and you're very welcome to our TechWorks Marine autumn webinar series. This is our first webinar of 2020. We're delighted to have so many people showing interest in signing up. So you're very welcome. We put some contact information at the end of the slide, so if anybody wants to follow up with anything, you're very welcome to get in touch with us directly. This webinar is being recorded at the moment and will be made available on our YouTube channel later on in the week. So if you'd like to send on the link to any of your colleagues or anything like that, if you find it interesting, we'll circulate the link to all the registered attendees, and we'll share it with everybody. So the topic of this webinar today is water quality assessment, bringing satellite and in-situ data together. So that's, I suppose, what TechWorks Marine is all about. So I'm just trying to move on to my next slide. There we go. So myself and Emer are co-hosting the webinar today. So I'll be giving the presentation, then Emer will be kind of dealing with the question and answer session at the end. Just in terms of collecting the questions and passing them on. My name is Sinead Lynn. I'm the Earth Observation Manager here at TechWorks Marine. Emer is one of our Earth Observation scientists. And I suppose the first thing that we'll do is give you kind of an overview of the company and what we do. The kind of structure of the webinar is here, so we'll just have a little bit of housekeeping information first, and we'll give you an overview of the company and talk through a little bit about why satellite data in particular is useful, so for anyone who's not very familiar with the use of satellite data. And we will then talk a little bit about the current project that we're doing at the moment. So it's called CoastEO, and that means Coastal Ocean Assessment using Earth Observation. So this project is an 18-month service development, and it's funded by the European Space Agency, ESA, under their Investing in Industrial Innovation programme. So this is a programme which is specifically aimed at the commercialization and the adding of satellite data to services to enable users, I suppose, to get the full value of the satellite data that's made available through the Copernicus program. So I won't talk about the Copernicus program in much detail because I think possibly a lot of people are familiar with it, but basically the Copernicus program is the European Union's flagship program with ESA to provide regular, full, free and open satellite data globally through a series of satellites which are called Sentinels. So the data that's used from here, the data provided by the Sentinel satellites is, sorry, there's a notification coming up here. Oh, sorry. Yes, so the Sentinel satellites provide data which is full, free and open and accessible to the global community for use in research and commercial purposes. So I'll talk a bit about the project and talk about the kind of current status and what we have been doing, what we plan to do next. And then at the end, I'd encourage everybody, if you have any questions or if you have comments or if there's something that's come up during the presentation that piques your interest, please speak up. And if you don't want to speak up during the webinar, please feel free to contact us afterwards and have a chat. So here's some just minor housekeeping rules. I think most of these people are well familiar with at this stage. So as I mentioned before, the webinar will be recorded, so that will be made available afterwards for further digestion or for you to pass on to your colleagues. We'd ask for the moment to just keep your microphones muted. I think that's the case at the moment anyway, but what we've done is allowed people to unmute themselves at the end for the Q&A. If you think of a question as it comes along, as the webinar goes, please add it to the chat box and we can address it at the end. And it also helps as well if you add either your name or your organisation to the question, because it helps us to understand where you're coming from then as well. In general, short specific questions help, but that's not a hard and fast rule. So first of all, just to talk a little bit about what the company does. So our tagline is robust, reliable, secure marine data, and that is essentially what we do. We provide marine data as a service, and we do that in a couple of different ways. So a large fraction of our business is around data buoy deployment. So we provide an end-to-end system where the buoy infrastructure, the data acquisition system, the data transmission, the data portal is all provided as part of our service. So we assemble the buoy, we attach the sensors, we assemble the data acquisition system, we put it on, we deploy the buoy, we provide access then to our user portal, which is called CoastEye, which I'll talk about a little bit later, so that the client can visualize the data at the end. The data is transmitted then either via GSM or via Iridium to the CoastEye portal. And then the final piece of the puzzle is the complementary satellite data, which can be used to give you a much larger scale picture rather than sort of localized areas of interest with buoys. So the buoys will give you very local high resolution information, and satellite data will give you a larger scale on that, so you can combine the spatial and the temporal data together. So our website is down in the bottom corner if you're interested in knowing a bit more about us. This is an overview of what we do. So we've got a couple of examples here on the left. So this is one of our larger data buoys that's been deployed in Dublin Bay. So as I mentioned, it's a sort of an end-to-end system. So the data buoys provide information in real time, and the data acquisition is performed through our proprietary technology. And we have a wide range of sensors which can be deployed on the buoy, so we can measure various things like turbidity, chlorophyll, surface temperature, through column temperature, currents, wave heights, and so on and so on. We provide a range then of different communication mechanisms for that as well. Our data management and delivery then is done through our CoastEye portal. So that includes maintenance information for us as the field team or for the client, so that you know when there's maintenance is required to be done on the buoys, so keeping live information coming, both sort of internal and external information. Data management, so being able to provide everything from quality assurance and calibration. And then on top of that, we provide value-added products and services. So for example, using satellite data products, also providing information around models, a couple of other aspects of the business that we do is met-ocean survey provision. So we'll go out and do manual sampling or surveys for specific areas, for specific regions. And then also we provide, we're a third-party seller for a lot of oceanographic sensors, so we provide sales, rental and maintenance contracts for those. So that kind of is a summary of what the company does in general. We're a small enough company, there's 13 of us at the moment. We're based in Dublin, just a bit outside the city centre, but close to the coast so that we can carry out our work as needed. And our team is kind of made up of mechanical engineers, marine scientists, EO scientists, software engineers, oceanographers. So it's a very diverse team with a lot of very kind of complementary specialities. The CoastEye data analytics platform itself has been developed in-house and is our operational platform, so it's what we use for our day-to-day services. So it's used both by us and by our clients to manage and monitor all of the deployed systems and platforms that we have currently in the water. So from the Irish coastline to European coastline to Middle Eastern coastline to Caribbean coastlines. We've had experience in a lot of different areas, and it's all around using the same data platform. So the platform can be used to visualize the in-situ data, and you can see just an example down here. This is just a measurement of chlorophyll data over a long period of time. It's also, the platform can be used then to also visualize Earth observation data products. So corresponding example here will be the chlorophyll from the Sentinel-3 satellite, which is a satellite designed to measure ocean color and oceanographic measurements, particularly from the imagery side. So we can also then compare the Earth observation and in-situ data to validate one against the other. And this is kind of a very important part of the satellite data aspect, because you need the in-situ data to be able to make sure that what satellite data is telling you is correct. You can then extrapolate over a much larger area to give you confidence in your measurements. There's also functionality on the platform to download the data that's collected. So in terms of downloading the data in a report form, so that you can just import the images directly into your own information, or download the information which can be plotted or used for further analysis. And just up here on the left, we have an example. So this is one of our data buoys that was deployed in Dublin Bay last year, which is measuring the radiance, so the amount of light that's scattered at the surface of the water, compared to Sentinel-2, which is another image-based satellite. So we've done quite a bit of work on this over the past 10, 11 years around validating satellite data using in-situ data. And that's kind of what our project is going to be all about. So just to provide a bit of context, really, I mean, for those who haven't used satellite data, or have heard a little bit about it but don't really know what the benefits and what the advantages are. So why is satellite data so useful in kind of day-to-day work? Well, the first aspect, which I mentioned already, is that it provides data over a larger geographical area than in typical in-situ campaigns. So if you're monitoring an area, you have to basically send people out to do it, and it's a bit more time consuming, it's a bit more involved, a bit more planning involved, whereas the satellite data can just provide you with information over a larger area. Because there are historical records available, so because the satellites are designed to be compatible with previous satellites that have been launched in the past. There are historical records back to about the 70s in some cases, which can be linked together. So you can really monitor and assess your current status, but you can also assess any changes in the environment that you can see over a large period of time. In general, the data can be quite complex to process and can be a bit awkward, or it can take a bit of time, a bit of training to figure out how to process the information. But the good aspect of that is that the information that is produced is then generally quite easy to understand, so it's quite clear. When people look at a geographical image, or they look at a plot of NDVI, or even turbidity or some sort of water quality parameters, it's quite easy to understand it directly. It provides a method for measuring compliance. So while this is something I think that's more of a long-term aim, it allows organizations to monitor things quite easily, and can be used then, I suppose, to validate or to provide proof of compliance with permits and licenses for activities such as construction or dredging, or you know, urban activities, that kind of thing. And the increase in processing power that's available and the increase in data that's available over the last few years has really led to an explosion of interest, and the fact that people can realize that you can get really useful information from satellite data. So I'm just going to show a couple of examples from our demonstration platform. So we have our CoastEye kind of operational platform, but we have a sort of capsule version which we use for demos to people. So if you're interested in having a look at the demo, or one of us showing you a demonstration, please get in touch with us. This is an example, again, off the coast of Dublin, of what you can do in terms of measuring long-term records. So this information is from MERIS, which was an instrument on previous satellite called ENVISAT, so in the kind of mid to late 2000s. And the resolution on this is about 300 meters. So while it's quite coarse resolution, you can get a really good idea of the kind of large scale information. And it's possible from the satellite information to generate both the mean chlorophyll on a monthly basis and the mean turbidity. So we can also calculate the standard deviation from each of these measurements. So this is what's plotted down here along the bottom. It's just a plot of the mean chlorophyll and the mean turbidity over the period of about a year, so you can see the evolution. So it just makes it a nice, easy way for you to see directly what the current measurements there. So one particular monthly measurement, 6.65, is visible on the screen here, but you can see then the overlying trends as well. And what's done here is that we take an average of multiple pixels around the particular area it's being looked at, to give you kind of a really good statistical overview. So the counts that are there will show you how much data has been collected over the course of the month. Another example, which is something that my colleague Emer has been working on. So the MERIS information back in the previous slide was 300 meter resolution, but Sentinel-2, which was launched in 2017, 2018. The Sentinel-2 resolution can be much higher. So in this case, we're looking at 10 meter resolution, which is the highest it can go. So being able to go from comparing or from looking at information over a very large area, you can then zoom right down into your local region of interest. So for example, here, this is Dublin Bay, but this data is available for any bay around Ireland or France or elsewhere. And what we've done here is just compare the turbidity data that's being determined from the satellite against turbidity data that's being collected by some of our live buoys in the bay. So we've had 4 buoys in the bay since 2017 as part of a commercial project. And you can see that the in-situ turbidity and the satellite turbidity are compared quite nicely for a couple of different regions. And you can always see then, you can see quite clearly when the tide is in, the tide is out for the satellite measurements. But it's a good demonstration that you can get quite consistent and well-matched data between turbidity from satellite and turbidity from in situ. Another example then, this is kind of more what could be done, because there's been quite a lot of talk about this over the past year and a half maybe. So here's an example of Ringsend wastewater treatment plant in Dublin. And so it's at quite a high capacity at the moment, and there have been some leaks, especially when there are high volumes of rainfall in the area. And what happens is that this causes plumes of sort of semi-treated water to be ejected. So you can see here, the RGB image can show you quite clearly some of the plume from Stoke Bay. The wastewater treatment plant is right here. You can also see this is total suspended matter image, so you can see that the plume is coming out quite clearly. But what happens is that the beaches all along the south Dublin coast then have to be closed because there's a risk of E. coli being present in the water. So something that satellite data could do would be to basically monitor the evolution through the total suspended matter and monitor the release of plumes into the water, and sort of allow organisations to track the releases of the plumes, and also then to track how often the beaches then need to be closed. This is something that may carry on for another couple of years until the wastewater treatment plant is completely upgraded. So it's something that could be monitored on a very regular basis. So that's some examples of what you can do with satellite data. And this is sort of an overview then of the project that we're doing at the moment, CoastEO. So what we have been doing, as I mentioned, is doing a lot of work around the validation of satellite data with in-situ information. And we've done a lot of work with very high resolution, high spec, expensive sensors. Part of the reason that we started this project for CoastEO was to look at, can you do this on a sort of a smaller scale? So can you have something that's quite small and easily deployed, but can still be used to validate the satellite data? And so we have our low-cost buoy platform called a Mini-Buoy, which you can see here in the image, which I'll talk about a little bit more in detail in a minute. But you can see from the size of it, it's quite small, so it's smaller than the canoe by a large bit. So it's providing the localized in-situ information to CoastEye. We can then combine that with the satellite data collected by Sentinel-2 and Sentinel-3. And we've been doing a lot of work on processing chains to validate the satellite data using the in-situ data. And that's then what can be provided through CoastEye. So the timeline for this project, we started it in January this year, and it's going to go on until July of next year, so it's 18 months. And who the clients or the users that we think would have an interest in this would be companies like, or organizations like port authorities, regulatory agencies such as environmental agencies, water agencies, companies who are obligated to provide compliance to permits while doing work. So being able to put something into the water and locally to say, okay, you know, while we're doing this work, we're able to keep an eye on the water quality and to make sure that there's no, there are no issues. The aims of the project are to reduce the time and the cost to the customer. So being able to provide the customer with the in-situ data from the buoy and the satellite data, and to provide an end product which is thoroughly validated and based on and provides metadata around the collection methodologies. So the idea will be then to provide ongoing environmental water quality monitoring via Earth observation. Our Mini-Buoy has been developed in-house, so we kind of identified, I suppose, a gap in the market where most of the buoys that we would use would be a couple of meters in height and a couple of meters across. So very kind of large scale, very expensive, very expensive to deploy, relatively straightforward to maintain, but very visible, requires foreshore licenses to be put out in the water, and requires zones where you don't allow any shipping anywhere near them to keep them safe. The Mini-Buoy is a much smaller, much more compact version, and is also a stripped down version of what we would use in our normal data acquisition systems. So it's much lower power. So you can see there's a buoy in the water here that doesn't have, it's battery powered, it doesn't have any solar panels or anything on it, it's powered by a battery, which we have calculated will last between 4 and 6 weeks, depending on the number of sensors that are attached and the sampling frequency. So it's been designed for real-time monitoring in coastal and freshwater environments. So you can see here from the picture, there's a couple of people handling it. So it weighs about 35–40 kilos. So it can be deployed quite easily off the side of a boat. So you don't need to have a lot of complicated equipment to actually deploy it. You can deploy it off the side of a boat easily, and either a small chain or something kind of straightforward for mooring options. It has a number of flexible input options, so it's been designed to deploy up to 3 sensors at a time. So you can have, if you have a multi-parameter sensor on there, you can measure up to maybe 9 or 10 different parameters. There are a number of flexible telemetry options, so we're looking at, there are a couple of different ways of doing it, but you can basically integrate the data, collect the data, just visualize it on CoastEye on a very kind of fast turnaround basis. It has a very flexible sampling methodology, so you can tell it how frequently you want to sample. So if you're looking at putting the buoy into the water for alert purposes, once you get an alert to say, okay, there's an increase in a threshold parameter, you can then set it to sample more frequently. So while there is an increased rate, it will sample more frequently, and then you can reduce it back to sampling, for example, every 15 minutes or so. It also, because it's quite small and quite low profile, it can be, it's quite unobtrusive, so it's not, it can be deployed in locations where maybe we don't really want to advertise that you're that you're monitoring something. So if you're trying to keep an eye on activities from other organisations, it can be deployed and is generally quite low profile. And it provides basically a full monitoring and warning system. So it's a lower power, small scale version of the buoys that we do currently deploy, but it provides the same sort of functionalities. So combining the Mini-Buoy and the satellite together, here's how the CoastEO service is going to work. So basically step one would be to deploy the Mini-Buoy or Mini-Buoys into the water and collect the data, collecting the simultaneous satellite observations. We would then process and analyse the data and provide the we've designed the processing chains to do that. So we do the analysis, basically all the hard work, and then the information is visualized on CoastEye. This then is made available to the end user, so in various forms of information, for example, for alerts, if the client has requested alerts for particular thresholds, we can provide that, or we can just provide the sort of ongoing measurements for monitoring for a specified period of time. So as I mentioned, the Mini-Buoy has a battery life of about 4 to 6 weeks. So what we're really talking about is kind of fairly short-term deployment. So if you're just trying to look at you know, something specific in a kind of a localized area. Some of the work that has been done already for the project, we carried out a survey during the summer, which we are actually which we're going to reopen again. So we'll provide the survey link at the end of the slides here. We had a few questions, I suppose, about how organisations were carrying out their current water quality monitoring. So it's quite obvious that there's data from many sources out there already. So whether people are collecting the information themselves or using public organisations or private organisations to collect and provide the data for them. We identified that many people who did have previous experience with satellite data had some issues around the analysis and around the sort of the access. So one thing was that the data, although the data is available through a range of different sources, but conversely can sometimes be quite hard to access the specific data that you're looking for. The analysis process can be quite tough, so a lot of the times training is necessary, and sometimes there is almost too much choice, so there's too many different products out there without enough information. Some of the different parameters that people were interested in measuring are up here on the top right hand corner. So in terms of the satellite data, turbidity was #1, and actually in-situ turbidity was #1 as well. So you can see that a couple of these are overlapping quite nicely. So there are ways to measure both, to measure parameters in using two different methodologies, which are complementary and can validate each other. Just at the bottom here, I have an example. So this is an RGB image of the ocean colour in the Irish Sea and the comparative chlorophyll index. So you can see quite clearly in the RGB image that there's a lot of eddies, a lot of turbidity going on, and that's kind of reproduced then what you can use the chlorophyll measurements for, is to see, is that actually chlorophyll or is that just sediment or you can distinguish between the two of them to see are they due to blooms or just due to turbidity and freshwater coming into the ocean. So the survey threw up quite a lot of interesting aspects for us. So what I've done is kind of focus a little bit on how the issues that kind of came up during the survey, how we can hope to help people with them. So how can CoastEO address these issues? So I think I've mentioned already, but I will go through again the kind of the benefits for users in particular. So one obvious large benefit is that it reduces the time and cost for manual sampling at different sites. Doing the processing and the analysis and producing the visualizations on our side allows any end users then to focus just on their core competencies. So it allows them to focus on the things that bring them value, and the validated EO information can be brought in then from the CoastEO service. It enables larger scale monitoring, so you can look at an entire region. And as I mentioned, in the long term, I think at the moment, it's quite difficult in terms of reporting through the EU Water Framework Directive and those kind of other directives. They don't really, the methodologies don't really include satellite data at the moment, but this is, I think, a long-term plan. I'm sure lots of organisations will be keen to actually be able to use the satellite data to provide very specific compliance details. So the next things that we're going to do within the project between now and Christmas, we're incorporating any user feedback from the survey and from the question and answer session we hear. We're finalising the development of our algorithms. So, for example, in terms of the turbidity, we're collecting a lot of the historical turbidity information that we would have in-house to build up a really decent validation algorithm. And we're also then planning to do a test deployment of the Mini-Buoy in Dublin Bay, possibly in the marina in Dún Laoghaire to gather in-situ information, to be able to then use that as a demonstrator. So that will be something that we will advertise, and we'll share the results from that with anybody who's interested. So the real, I suppose, point and real aim of the CoastEO project is to provide very reliable in-situ monitoring, to provide high-resolution validated satellite data, and to use those combined together to provide easy-to-access water quality information through our portal. And that's the sort of the take-home message, I suppose, really from this webinar, is that we would really like people's input or people's feedback. If you'd like to sign up to be, to see demonstrations and to receive kind of test data, or to be a beta tester for us, please do let us know. So here is the information that I think I've mentioned already. So we have a CoastEO project website, which I've put the link up there. So if you want to keep up to date with how the project is going, please visit that page. We've just reopened the survey as well. So if you have any input or any feedback that you'd like to put in there, please do. Our Twitter handle is TechWorks Marine, so you can find us on Twitter, and my email address is down there, so if you want to get in contact with us to talk about anything specific or to you know, get an overview of what we're doing, please go ahead and do it. Okay, so I think that's it. So, Emer, do you want to say anything, or I suppose I think we've.
There's one question in the chat there, just regarding a slide a few previous slides ago. From
Yeah.
So you mentioned turbidity and chlorophyll A. What other water quality parameters can we measure, and at what locations, e.g. bays, coastal zones in Ireland, have been covered?
So the water quality parameters that we would measure, generally we'd have a lot of in situ information. So we've measured waves and currents with ADCPs and in certain locations. We've also done some measurements with multi-parameter sensors, so measuring temperature, conductivity, pH, chlorophyll, temperature and pressure. I suppose most of the areas, so we haven't, most of the information that we've taken at the moment has been historical information from previous work that we've done. What we're looking at as the kind of the next stage then after Christmas would be to do some deployments in some specific areas. So Dublin is kind of an easy and a kind of an obvious one for us, but Zainab in particular, if you have areas that you'd like to look at, we can always look at a kind of a test deployment for something, you know, specific for you. Okay, I see here a question about, is it possible to measure directly or indirectly pH and electrical conductivity from EO? pH, I don't think so. Conductivity, I guess you can measure the sea surface salinity from EO, which maybe could be used as a proxy, but I'm not completely sure, Mazuma. But I hope that helps a little bit. A question from Donna, can this be useful for freshwater river environments? Yes, absolutely. So we've designed it for, because we're a marine company, we initially, our buoys are generally deployed in coastal areas. So we don't deploy buoys out very far into the ocean. We're always kind of looking at the coastal kind of estuarine environment. And so, yes, the sensors that we have can be used as well for freshwater environments. I suppose the only thing is that if you, well, no, it's you know, the sensors are all designed to monitor both freshwater and marine, but just generally the marine sensors are more rugged because they need to be protected against the corrosion. So I hope that answers your question. I see a question as well from Phil Mumbai. Happy to have more details about specific involvement to address the Marine Strategy Framework Directive. I guess that's just a comment. Maybe we can follow up with you after that. Yeah, so just wondering if anybody else has any questions or anything like that. mean, one thing I didn't really talk about in too much detail, but I mentioned there, like we're happy to get kind of potential users to suggest locations for deployment. So similar to what Zainab was asking, we haven't identified specific areas for testing yet, but if there is a specific area that you're interested in looking at, you know, an area that's of interest to you, we'd be happy to have a conversation about it. As I mentioned before, it's kind of, they're designed for quite short-term deployments, so for a couple of weeks at a time, so we can look at a couple of different areas as well. The important question. So from Neve Flynn has asked, what is the cost of the Mini-Buoy? So the project that we're talking about here, we don't generally talk about, we're not looking at selling the Mini-Buoy directly, we're looking at selling or providing the information from the Mini-Buoy itself. But the average cost of the Mini-Buoy, it kind of depends on what sensors are deployed on it, and the actual frame and structure itself is kind of you know, is not super expensive, but the sensors can be, you know, anywhere from a few hundred euro up to a few K, so it kind of depends. We're looking at maybe an average cost of the Mini-Buoy might be about 10K depending on the sensors. Can the Mini-Buoy be deployed in intertidal areas? Yes, I suppose it depends on how intertidal. I mean, the Mini-Buoy itself is about 1.2 meters in height, so the frame underneath where the sensors are fitted or attached, and the total height is about 1.2, so it's only about half a meter above the surface. So we have deployed, it has been deployed in quite what's the word, in estuarine zones anyway. So yeah, I think, you know, it depends on the depth, but yes, it can be deployed in tidal areas. Zainab, you're very welcome. What is the lead time for deployment of a Mini-Buoy? Well, at the moment, we have about kind of 2 or 3 systems in the office. We have developed a kind of a fully working one, which is actually provided to the EPA, and since then we've been working a bit on sort of optimizing the data transmission and the electronic side. The lead time for deployment will be probably, I'd say a couple of weeks maybe, in general. It kind of, you know, it depends on what depends on the area, maybe depends on the sensors that are required. So it may depend on the lead time for the sensors as well. Yes, Charles mentioned there 4 to 6 weeks, which is kind of our average deployment time. Anybody else think of anything? Oh, I see another question coming up. Is a foreshore license required for the deployment of the Mini-Buoy? No, because it's quite a small piece of kit. I think there isn't a foreshore license. But what we would do, I think, would be to have discussions with the relevant kind of local harbour master or wherever it would be deployed, just to make sure that it's kept somewhere where it's you know, safe from accidental damage, but the forestry license isn't required for it. Yes, as Charlotte mentioned there, we put out a marine notice just so we would notify the sort of the local traffic in the area so that they'd be aware of it. So I guess if that's it, if you do, of course, if you think of any other questions or anything like that, please feel free to get in touch with me, and we'd be quite happy to talk to you. As I mentioned, we'll have this webinar recorded and we'll make it available for any of your colleagues or anything like that to watch. And I suppose, oh, got one more question. Have we tested any rivers to date? We haven't tested, it's the Mini-Buoy that's owned by the EPA has been tested or has been used in some lakes. We haven't tested it in any rivers, but yeah, it's been tested in kind of in lakes and in harbour areas without any issues. Okay, so what I can do as well is I'll put these slides up on our website, and we can tweet out or email out a link. As you can see, the survey and the information are available here, and we can either email you the links or you can click directly on the links. But we'd be, happy to have a conversation. And if you want to fill out the survey, please do. Sorry, there's one more question. Yeah, so Emer has just put the survey link into the chat box there as well. Are we using the L2, L3 data for chlorophyll and turbidity measurement, or are we developing our own algorithm? I might let Emer answer that one, Emer, if you don't mind.
Yeah, no problem. I think it's a mix of both. So for the turbidity, I'm testing different algorithms from the literature. So mainly single band algorithms based on reflectance values for the water type, the specific water type in the region. And so currently doing an awful lot of processing with that, and then statistically testing the results, and it's looking good so far. If you want, I can email you on some further details with literature review and stuff like that as well.
Don has asked, can sensors measure noise? So no, the sensors that we would use would be oceanographic sensors. So we're measuring water quality parameters more than noise. So yeah, we would look at specific water quality. I think as mentioned above, turbidity, chlorophyll, pH, temperature, those kind of things, and not noise. You're very welcome, Donna. Okay, so I think maybe we will leave it there. Yes, Charlotte's mentioned we measured noise on our larger buoys, and if you would like, again, if you'd like to get in touch with us, we can give you a bit more information about that. I think I can wrap it up now because it's 5 to 5:02. I don't want to keep anybody more than an hour, but thank you very much to everybody for attending and for listening. Thank you very much for your questions. And yeah, please get in touch if you want to talk about anything in particular. Thank you very much to Emer for co-hosting with me and helping me out. And yeah, please get in touch, and we look forward to speaking to you again.